technologies, opportunities, and challenges. So, myself, Arjunraj, I am a technical innovation and VAVE consultant. I am also a technical committee member in Imperial Society of Innovative Engineers. In addition to that, I am into the education committee member in Miles Valley Foundation USA. I am also a South Zone Council member in Indian Value Engineering Society. So I can be contacted at p.arjunraj@gmail.com, and my mobile number is 8778983428. You can post your questions even after the session. You are free to ask the questions even during the session also. Okay. So today my presentation content will be the chronology of electric vehicle, and then I will cover some basic concepts and terminologies of electric vehicle, and I will give overview about electric bus technologies, and I will give overview of the electric two-wheeler concepts and applications, overview of some of the case studies I have done with respect to the Ether and also the TVS Vigo electric vehicle, and some of the electric vehicle and their performance, and then the importance of the electric vehicle performance and the evaluation of the electric vehicle, and finally I will be closing the session with a case study on modeling and simulation of electric vehicles. Okay, the first topic is electric vehicle chronology. So, as the name indicates, the chronology, which means the history behind the electric vehicle. So, when the concept had been started and where we are now, and what are different type of the morphology that have taken place since the starting of the electric vehicle. So, here you can see it's not a new concept again. So, in the early days of 1835, where the Americans they started the first electric carriage, and the hybrid technology started in the year 1965, and Tesla also came into picture in the year 2010, and before that, US US team had also tried with the hydrogen fuel cell hybrid as well, and there are some other transition that happened with respect to the hydrogen and also the fuel cells and also the hybrid. And we can also see the plug-in hybrid vehicle had taken a very great leap after 2010. So as per the strategies of 2007, almost 10 lakh or 1 million hybrid vehicle are being sold worldwide. And in the year 2009, 2 million hybrid vehicle are being sold worldwide. And in the year 2011, 3 million hybrids are being sold worldwide. So now we are in 2020. So uh, now there is a huge time for the electric vehicle and hybrid vehicle to come into the market, and I am sure uh, there will be a great leap in forthcoming days for hybrid and also for electric vehicle. So here, when I said electric vehicle chronology, so you can see there are a lot of morphology has taken place. You can see in India, we are having the electric Reva, Mahindra E2O, BMW i8. So it started in the year 2001, and now we are in 2020. And for the past 3 years, the companies like Nissan, Tata, Hyundai, Mahindra, they have done a lot of, they launched a lot of new cars like Mahindra EKUV 100, Mahindra NXT E20, and Tata Tiago, Nissan Leaf, Hyundai Kona. So you can see a lot of development had taken place for the past 3 years. And it's not only in the cars, and also you can see we are having electric bus as well, which has been launched by the leading players like Mahindra and Mahindra, where they launched the EC Pro, and also Ashok Leyland. They created buses, followed by the Tata, and even the IHR companies also created the electric vehicle, electric bus basically, and JBM Group as well. So there are a lot of market players are there in India, and they are also launching the different products. Uh, and I can say for the past 3 to 4 years, both electric bus and also electric car had taken a great leap. Okay, so coming back to the electric cars and also the SUV category in India, so we have the three major vehicle like Tata Nexon electric vehicle, MG Motors EZS electric vehicle, and Hyundai Kona. So it is basically a comparison between the three vehicles. Uh, so here you can see the length is starting for the case of Tata Nexon, it's 3,994, and in the case of MG it is 4314, and in the case of Hyundai Kona it is 4180. Followed by that we have different width and height, and you can see the ground clearance is quite less for Hyundai Kona, whereas it's more for Tata Nexon. And the thing what you need to look here is the range. Okay, the range and the torque. So when the torque is more, obviously the range will also be more. So you can find the Hyundai Kona is having 395 Newton meter torque, which is much more higher than the Tata Nexon and MG motors. Obviously, you can find the range is also on the higher side. And again, the acceleration is also quite comparable between Tata Nexon, MG, and Hyundai Kona. So, and obviously, the most thing what Indians will be looking is the price. So the price is varying between 14 lakhs to and also to 23, 24 lakhs, close to 24 lakhs. And okay, so when I say the electric automotive mobility, it's having the two-wheeler application, auto application, and also the e-rickshaw application, and also we also have the bus application as well, bus, trucks, and some of the commercial vehicles. Okay, so here we will be starting with the basic concepts and terminologies that what we'll be using in electric vehicle. So we have three type of electrification. One is the conventional electrification. Next one is the hybrid electrification, and the third one is the battery electric electrification. So the electrification first one is the conventional one where we have the fuel. So we use either gasoline or a diesel as a fuel. We have a normal transmission. Okay. So when I say hybrid, it indicates both engine as well as electric motor. So when the vehicle is having the regenerative braking in it, then the motor will be acting as a generator. You also have the transmission. Of course, the transmission what we use in the conventional vehicle is quite complex, whereas in the case of uh, pure electric, you can run the vehicle with the help of a single speed gearbox. But in the case of the conventional, you need to go for a multi speed gearbox. And again, it's a bit complicated in the case of transmission. But when you're going for a pure electric, the transmission is quite simple. On the other hand, when you're going for a hybrid, you can have the same transmission what you're using for the conventional one. At the same time, so hybrid indicates you can run the vehicle either in electric motor or in the engine side. So, for example, when the vehicle is running in the traffic where there is no where there is huge traffic, by the time you can operate the vehicle using the starter motor or a electric motor. So when the vehicle is running in the bypass or the highway, you can operate the vehicle in engine mode. This will also save the fuel. And again, if in case if the electric vehicle or the battery gets discharged, then you can switch the vehicle to the engine mode. So hybrid application is quite interesting. And in the case of electric vehicle, you don't have any engine, so you have only the motor and generator. So here also you can use the regenerative braking principle, where by the time of regenerative braking, the motor will act as a generator. So the transmission will be a single speed gearbox. So, and again, the last slide is electrification, and this slide, what you are seeing on the screen is hybridization. So you have four type of hybridization. One is a micro hybrid, mild hybrid. Third one is a full hybrid, and the last one is a plug-in hybrid. So when I say it's a micro hybrid, it indicates the automatic start-stop application for the engine, basically during the traffic condition. So the next is the mild hybrid, which indicates not only the start-stop application but also it's having the regenerative braking, where it operates above 60 volts, and it also having the electric motor to assist the engine. And also you can see the full hybrid indicates it can also drive using the electric motor. And the last hybridization is nothing but a plug-in hybridization, where you can also recharge the battery from a outlet wall to that of the extensive electric range. So you can find some of the example of different vehicle having different hybridization. You can see the Citroen vehicle C3, which is having the micro hybrid. Honda Insight vehicle is having the mild hybrid application. Toyota Prius is having the full hybrid application. And the last is Chevy Volt. It's having the plug-in hybrid application. Okay. So now I'm going to compare the different type of energy losses between the electric vehicle and an internal combustion engine, and also the hybrid vehicle. So I'm going to take different case studies. Case study in the sense when you're driving the vehicle in city and when you're driving the vehicle in highway, what will be the behavior of the energy losses between the combustion engine and also the battery operated vehicle, and which also indicates hybrid as well. So here, in the case of internal combustion engine, we have the fuel tank, where this is the input for a source of energy having 100 percentage. So when it is coming out, 100 percentage is been reduced to 13 percentage, because you have a lot of losses. Okay, engine is having a lot of losses. You have 76 percentage loss in the engine. So you have blowdown loss, blow by loss, and you have exhaust loss. You have heat loss, time loss. Because of these losses, your engine performance or the percentage it's getting reduced, and the efficiency also gets reduced. So this is the reason behind why either in city condition or in highway condition you get less percentage when the vehicle is running using the engine mode. And you also have some standby loss of 8 percentage, and of course you also have some driveline losses of 3 percentage. And with respect to vehicle, you cannot avoid the aerodynamic loss or the rolling resistance loss or the braking loss. This is quite common. But what we can concentrate here is more towards the powertrain area or the electric mode area. So and the next one is the highway driving condition. So in this 13 percentage will be having a slight increase. So 13 percentage will become 19 percentage when the vehicle is running in highway, because the standby loss is very less. It's not less. It's basically zero, because the vehicle keep on moving. So there is no standby loss. So this standby loss of 8 percentage is there when the vehicle is running in the city driving condition. So that is the reason you get 19 percentage efficiency when the vehicle is running in highway. Sorry, when the vehicle is running in highway, and when the vehicle is running in city, you get only 13 percentage. So you don't have the standby loss basically, and you also have the aerodynamic loss, rolling resistance loss, and also the braking resistance loss. Okay, so what we seen is the engine. Now what we are going to see here is the hybrid. So the percentage energy saving quite remains same between the engine operated mode and hybrid operated mode. But what the advantage you get when you're going for a hybrid system is that you can go for either hybrid type like full hybrid system, where you can also do downsizing of the engine, And you can also decouple the engine along with the flywheel and the wheel. And you can also go for a plug-in type of thing where you can eliminate the engine entirely. And you can also, when you're going for a micro hybrid, what happens is that you can eliminate the standby loss of 8% again. Okay, so when you're going for a electric vehicle, what happens is that you have 76% efficiency in drive lane efficiency. Whereas in the case of electric vehicle, you get only 13%. And in the case of when the vehicle is running in the highway, you get 19%. You can see there is a increment of almost 60% energy loss is not there in the case of electric vehicle when comparing to that of the conventional vehicle. Okay. So you have the efficiency, what we call, which is nothing but the well to wheel efficiency. So the most of the power what you're going to get from the generation goes to the transmission. So and again the same thing we are going to use for a vehicle. So here you get 23 percentage. Okay, so and again when you can also get the power using the refining thing, and so here you get when you're pumping to the wheel, you get 13 percentage. So you can also use nowadays what the technology electric vehicle people are using is that vehicle to grid to vehicle technologies also. For again, you can also discharge and again you can charge it back. But you need to understand the well to tank and tank to wheel. Uh, you also have the losses when when uh, when the energy or when the electricity is been getting transferred from one station to another station, finally to the wheel. So this is quite sometimes worrying factor as well, because you see the 80 percentage what is been given as input, you are getting only 13 percentage output. And what 31 percentage what you're going to give, you're getting only 23 percentage. So there's always the loss is also happening, because of that the efficiency is also getting reduced. Okay, so as I said, you have three type of hybridization: micro, mild, and plug-in hybrid. So the, the plug-in hybrid is the very interesting thing, where you can also run the vehicle either in electric mode, and also you can also run the vehicle in the case of uh, the engine mode as well. So here you can see the graph comparing the distance traveled with respect to that of the engine on and off, and the battery on and off. So when the vehicle is running, when the vehicle is running in the city condition, the battery is being on, and when the vehicle is running in the highway condition, the engine will be on, and the battery will be in off condition. So the plug-in hybrid basically it's a electric vehicle operation where it starts as an electric vehicle, and then there is a transition will happen to that of to the hybrid operation, and it always requires engine on or for the full performance. So you have the factor called the EPA rating, which is nothing but uh, the Environmental Protection Agency rating. Uh, so you also have the different type of ranging, like the drive cycle basically. So the drive cycle here indicates the city condition, and also the highway condition, and also the real world driving condition. So we test using the different applications, like ranging between different condition as well, which can vary from warm to cold and cold to warm. Um, so you can see the graph here, which is the test procedure for a federal test procedure. And this is also dealing with the fuel economy as well. So you have a lot of terminologies that you need to understand. The terminologies indicates the state of charge, state of discharge, uh, capacity, energy, specific power, etc. So when I say what is called okay, so what is called a state of charge? So state of charge is nothing but the battery capacity, which is expressed as a percentage of maximum capacity. So depth of discharge is nothing but the percentage of battery capacity that has been discharged. So capacity is nothing but the ampere hour. So that is available when the battery is discharged at a specific current. It's basically the rate of 100 percentage from the start of charge. And you know the unit of energy, which is mentioned in watts hour, is basically when the battery is discharged at a specific current. So we also have the terminology called specific energy, where we use watts hour per kg per unit mass basically a kilogram. So you have specific power, the maximum power in watts that the battery can provide with respect to that resistance of the battery. So still there is talk going on. Like the gasoline or the diesel is the best perfect fuel. Okay, uh, you can see the lithium ion battery what we are using currently. Uh, the energy density is very less when compared to that of gasoline or a biodiesel. So that is the reason still the people feel that almost the perfect fuel what we can use it is a gasoline. And still we can also go for CNG, LPG, but because of this energy density issue, many people feel that gasoline is quite giving more benefit. And still, when comparing to the pure electric, people still believe on hybrid system as well now. You can see the energy equivalency. When you're using 1 gallon of gas, you, what is the energy equivalency you get? Okay. Uh, so here you see you get 135 megajoules of energy. So using the 21 lithium ion batteries, and you see the the weight comparison between the gas and then with respect to the battery. You see the gas will contain only 2.7 kg of weight, but when you're going for a lithium ion battery, you see the weight. So weight is quite more actually, but this weight is for the same amount of energy. So that's why even CNG LPG is also good, but this is one of the drawback that we have with respect to the battery again. And you get 54 gallons. But on the other hand, the gallon size it's also higher in the case of battery operated system. So you have different issues when you're going for a electric vehicle. But what you can do is that you can cover this range anxiety with the help of fast charging. You can also go for a fast charging, or you can also swap the batteries. So this is how they are removing the battery and then they are putting the new battery. Is just like battery swapping. And fast charging, you can also do it in 30 minutes, 1 hour. So we have different type of technologies for fast charging as well. Okay, so we have the batteries, which is the lithium source, the one which are available abundant in nature, and we Indians are Indian in India, the lithium are not that much constrained, and it can also be recyclable. So and again, when you're doing recycling, you can get 90 percentage. You can get it back. It's again recoverable, and you can also extend the battery life. And you have very good battery management system when you're going for the lithium ion. And the weight to that of the volume direction is also quite less, because when you're going for a lead acid battery, the weight is still more. Okay, So comparatively, when compared to that of the lead acid battery, the lithium ion is quite good with respect to the weight and also the performance again. So what you can see here is the Tesla vehicle having the top speed of 125 miles per hour. The acceleration is 0 to 60 in 3.7 seconds, and you can see the range 244 miles it can go, and the cost is quite high, where it is 1 lakh 10,000. Okay, so these are different type of uh, trends that normally we have in automotive industry. So it's like V2G or vehicle to grid. You know about this vehicle to grid. So from the vehicle, you can discharge, and you can again you can save the power, and you can put it into the grid, and again whenever it's required, again you can put it to the vehicle. Grid to vehicle is also there. So autonomous driving is also the quite upcoming mega trends that we can see. And you have the connected vehicle, you have the shared mobility, you have Ola, Uber, uh, and Didi you have, and it's also IoT. IoT is also the upcoming technologies that normally we can use it in electric and hybrid vehicle, and cybersecurity as the one. So now I'll give some overview about electric bus technology. Okay. So you have three type of system in electric vehicle technology, and basically the bus technology. So first I will talk about the charging infrastructure, where you help of you have three type of charging. You can charge using overhead, where it's like in the case of railway, what you have is a pantograph. Using that you can charge, or you can also charge using overhead line. You have induction charging, induction, where when the vehicle is running in uh, dynamic condition, you can charge the vehicle, or when the vehicle is running in when the vehicle is standing in a static condition, you can charge. And you can also charge using plug-in mode also. So the next electric bus technology is energy storage system, where you have ultra capacitor, battery, fuel cells. Using that you can store the energy. You have different type of battery. So you have lead acid battery, nickel cadmium battery, metal hydride battery, lithium ion battery. So even now what we have is nickel, magnesium, cobalt. You have you also have uh, the lithium phosphate again. It's again lithium ion. LFP is nothing but lithium ion phosphate. So since the weight is less here and the energy density is much more higher in lithium ion when compared to that of lead acid and the nickel cadmium, we are going for this lithium ion. But the cost is quite high, and not too high, but it's comparatively high compared to that of lead acid battery. But the warranty, when you're talking about the warranty or the replacement, you need to replace the lead acid battery frequently. But in the case of lithium ion, it's not a case. And one way you're spending more money, but on the other hand, you can also the maintenance is also quite less when you're going for lithium ion. And the last technology what we have in electric bus is the propulsion kind of thing, where you have electric and hybrid. So and again in electric you have pure electric, and you have RWEV system. And hybrid is basically the parallel hybrid system. You have series hybrid system. You can also have the combination system as well. Okay, so I told you the three different verticals, and with respect to the electric vehicle carrier or the research opportunities, what you have in the case of electric bus technology is you have the research application with respect to the power electronics, and you also have the opportunities with respect to the connected vehicle and the electrochemistry, thermal management, where I am also working on this thermal management with some of the um, um, two-wheeler based companies as well. I'm also looking some of the consulting work now, and I am also working for some startup in the Pune based companies. for the thermal management research activities for a electric vehicle. So under the other upcoming is power electronics, material science and metallurgy, where you can reduce the weight of the vehicle so that the performance will be much more better. Electrical machine application you can go for, and you can go for power electronics. You can go for a control algorithm, and the last one is the vehicle engineering. So you have a lot of scope, and you have a lot of career as well with respect to research and also for a job opportunity as well. So this is the electric vehicle bus architecture. You see the line diagram. So you have charging. It can be the AC or DC charging, or it can be the DC flash charging. So this is flexible for any type of charging. And once this has been charged, you see you have the lithium ion battery with nickel, magnesium, cobalt, and this structure, this architecture is for a Ashok Leyland application. So the vehicle is having a lithium ion battery with 650 volts DC link, and it's also having the auxiliary power unit and the fuel cell auxiliary power unit plus controller it is having. And you see, it's also having the body control unit. You have the inverter, auxiliary inverter, and you also have the multi-speed gearbox because the torque is much more higher in the case of the commercial vehicle. So you need to go for a multi-speed gearbox application. And apart from that, you have the HVAC steering system and compressor system. Okay, so I told you you have three type of charging basically. One is overhead line. Next one is the pantograph type of thing where you can charge it using pantograph, like what people are using in the air railway as well. You can also go for a plug-in where you can plug and then you can do it. These three is very important, and and you can also charge the vehicle using the induction mode where the vehicle can move and you can charge it using the the inductive charging they call. So where the current and magnetic field will create an EMF, and the power what you are going to uh, get, what you are going to receive will get transmitted, and finally you get the charging as an output, and you get the required charging. So I'll give some overview of the electric two-wheeler, the concepts, and then application. Okay. So here, so I'm going to compare the matrix of systems and then the integration areas. So you see, you have different type of system. Basically, you have the suspension, brakes, steering, driveline, powertrain, HVAC, body work, electrical and interiors. And also you have different type of integration system like safety, weight management, dimensional, ergonomics, energy, performance, validation, regulation, change management, etc. And you also have the, and you see this all this area are playing a vital role in a two-wheeler application. It's not only the battery management system or the power electronics alone, but you see the other system what is been there in already is also playing a vital role between the system and then the integration area. Okay, so you see these are the perception about electric vehicle basically. Positive is been indicated in the case of blue and negative is indicated in the case of black. You see 95 percentage fuel efficiency is good, is positive in the case of electric vehicle, and only 5% people says it's negative. And the maintenance cost is less for electric vehicle, and the only problem is the riding range, which I'll come back later. People say even the pricing is also quite comparable for a two-wheeler basically. uh, I'm not going to compare with respect to four-wheeler where the price of the Tesla will be 35 lakhs, but the two-wheeler is quite affordable. That's what the, even the strategies or the data says. Um, and you see the charging infrastructure is also a problem. But if it is a four-wheeler, you have too much problem. But if it is a two-wheeler, then you can improve that, and it's not a difficult task, respect to two-wheeler at least. And the problem, what basically people say, is the riding range that that is there, and the model and appearance that you can go for some better aesthetics and ergonomics kind of thing. So you can have better model and appearance, and the charging infrastructure is not that much bad for a two-wheeler basically. However, it's quite complex in the case of a four-wheeler and commercial vehicle. But complex is not that too much complex again. So you have the low level of complexity or medium level of complexity. So and again, to maintain the dimension and size is also uh, uh, not that much easy, because you have the motor, you need to place the motor. When you're placing the motor or a battery, it adds additional weight, and that weight will come when it is coming to the wheel or the tire. Again, you need to face those design aspects as well, and the dimension size is it's not too much complicated, but there is some complication is there. Okay. So why we want to go for electric vehicle basically when compared to the internal combustion engine? Okay. So you know this torque versus RPM graph. So x-axis is nothing but RPM, and uh, this y-axis is nothing but a torque. When you're going for a internal combustion engine, you get the maximum torque when the engine is running in 2 by 12 of the maximum speed. But you can see when the vehicle is running, or when the RPM is at the start itself, you can find you have better torque in the case of electric motor. Okay, when you have better torque, your range will be better. Um, so this is the electric vehicle operating line diagram for a two-wheeler basically. What I have shown first is for a the electric bus technology application. So what I am showing here is the two-wheeler application. So it is having the battery, having a negative and positive terminal. So you have the bidirectional converter. You have the converter, bidirectional converter, and which is a form of DC and AC. And what is being used, it's basically the line diagram for a ether two-wheeler basically. So you have the motor and generator. In the case of regenerative, the motor will act as a regenerator, and you have the transmission, and it goes to the wheel. And you see, when the vehicle is running in regenerative mode, what happens? When the press when the ped when the driver presses the pedal, so what happens is you're going to get um, the changes what we can find between the two wheeler and the two wheeler electric, and also the high conventional fuel is that you have the petrol, but in the case of here what you have is the charging system, basically the electric charging system. And you also have the battery management system, and you have the motor controller, you have the electric motor. So you have different type of the motors and the motor controllers. So in the case of two wheeler, you have DC motor, PIDC motor, PMMC motor, AC induction motor, and switch reluctance motors. Whereas here you can find this motor is having the different application. So you need to select the motor considering the speed, torque, efficiency, reliability, and also cost. See, what example I am showing is a ether vehicle uh, having the hub type of drive, and also a belt kind of thing. So this is the example of a hub drive, where the hub motor is directly mounted on the wheel. Here you have less transmission loss, and it's also more durable, and it's also quite quieter in operation, and it's weatherproof, and it's also having more unsprung mass. Sometimes it will also damage your wheel because of the higher unsprung mass. And you can also go for a belt or chain drive using the change of gear, and you can you can also go with a chain drive with less uh, complexity, but what the difficulty here is it will create more noise, and the maintenance will be high, and it will also increase the overall weight. Only advantage is that it is easy to fix. So you have the battery controller, so basically the motor controller here. So uh, the battery management system in a ether vehicle. So the main function here is for the pre-charge, for the controlling system, and for the interfacing activities, for a balancing uh, thing, and for performance management, and for protection. This battery management system is very important. So here with respect to the charging system, so you have conductive system and also you have inductive system, where you can charge using AC or DC mode or static or dynamic mode, and you can also charge the two-wheeler with the help of the battery swapping. And this is quite quite playing a vital role in the case of a four-wheeler or a heavy-duty vehicle, where you have onboard charging in the case of the static, and you have the inductive system when the vehicle is running in the dynamic mode. So here in the case of a two-wheeler, you can also go for a battery swap as well, where you can change the battery. So here the advantage is it is having less wait time, but only the problem is that getting the standardized battery is quite difficult, and you don't have the range anxiety, but it also depends on the consumer acceptance, and the flexibility to charge the battery following the charging protocols. These are some of the pros and cons that you have. So you can see the integration aspects with respect to the two-wheeler application is basically a electric vehicle. So you have the motor uh, in the rear wheel, and you also have the high voltage battery. You have the charger here, and you have the DC load in the front side. You have the power drive unit center. Yes, we also have the sensors, meters, and the voltage battery as well. See, what the changes that you need to do when you're going for a normal vehicle to that of the electric vehicle. So the changes with respect to the center of gravity, suspension, brakes, tires, safety, NVH, and also for the regulations. Okay, so the center of gravity is basically less when you're going for a electric vehicle. Okay, because you're going to remove the IC engine and you're going to put the electric powertrain. The center of gravity gets lowered and the shift always transfer towards front side. And again, the next one is the weight distribution. It gets altered and calls for the design changes in various vehicle system, which indicates the suspension, brakes, and tires. The suspension is the next change that we can find in the case of the electric two-wheeler. Here it is very smooth, it's accurate steering you can go because you don't have a lot of parts, you have very limited parts, but on the other hand, still the weight is quite more because of the lithium ion battery. And the next is the handling will be good. It also supports the weight of the vehicle. And you can also modify the brake for electric vehicle based on the vehicle weight, load which is acting on the wheel during stopping, and also based on the vehicle drive behavior as well. So you have the drum brake, and the next one is the disc brake. You have can use either one of the two, depending upon the application and necessity. The next quite obvious problem that two-wheeler facing is the tire issue, tire chunking and tire noise issue, because you also have some of the issue of wear and tear of a tire because the load acting is more because of the motor. So that that again you need to select the motor based on the application, like whether it's low speed or high speed or high torque. So depending upon the speed and torque requirement, you need to select a motor, and you also need to ensure that you're not going to get a tire noise or a tire chunking issue because of the motor what you're going to select. And it's also having some uh, issue with respect to resistance coefficient as well. But uh, when you're selecting the correct motor, and if you're having less load which is acting onto the tire, then the tire issues will not come. And accordingly, you can also design the system or integrate the system so that you can have the better tire, and you can also you will not get any noises. Okay, the safety again, and the thing that we need to look for a two wheeler. So as you have the battery system, when the voltage is going on the higher side, so we always have some risk. Uh, and again, to avoid that, you can also go for a user interface. Um, so we have a lot of the indication system that will alarm the driver and the passenger. And you have the NVH. The next one is the NVH thing. The NVH is quite very less in the case of a electric vehicle when compared to that of engine, because you see you have a very huge noise in an engine when compared to that of electric vehicle, because you have a lot of friction when the vehicle is running in high speed basically. But the noise what we can find in the case of electric vehicle is the motor noise, but the motor noise is very less when compared to that of the engine noise. You can see the gap, how much is the gap. Um okay. So the next important thing basically that two wheeler needs to look with respect to electric vehicle point of view is that the RI standard test procedure. So the standard name is CAS 123. So all these things are very necessary when you're going for a regulation thing or a homologation point of view. So here they will look into the vehicle weight, the coast down test, they do the indication test, they do the gradability test, they do the brake performance test, they do the noise level test, the environmental condition test they do, and they do the functional trial, they do the traction test, battery test, ECU, and wiring harness test. So these are the tests that normally they do, and you need to ensure that all the test procedures have been met. Okay, so with respect to the two wheeler, what you have is you have different type of the batteries with respect to two wheeler. So you have the magnesium battery, you can go for a silicon based battery, sodium sulfur you can go proton battery, graphite battery, aluminum ion battery you can go nickel zinc. So you have different options basically. Okay, you can also go for A and salt water batteries as well. So you need to select depending upon your application. And the researcher says that sodium ion is also a good one. The battery grade salts of sodium having 30 percentage. Uh, they are also cheap and abundant. And what the researcher says that the cells can last longer when you're going for a sodium ion battery, and it can also go for more charge cycles. And the raw material, the sodium and the sodium ion raw material is 1,000 times more common, and they are also safer than lithium battling because lithium is not safe. And the availability of this sodium ion is also much more easier, and it's also easy to recycle. And only problem is the energy density is less. That is the quite worrying factor. But and again, the next worrying factor is high charging time. Again, the charging time is also higher. But apart from this low energy density and high charging time, the availability is abundant. So that is the way why the people are also looking for the sodium ion. The next one is the graphene, eh, where it is 5 times higher than that of lithium ion with respect to the energy density, but it is also expensive. So you have one advantage, another one is one disadvantage as well. It's also good for a better heat dissipation. It's also good for a quick charging. It's also having lightweight, and even Even you can also go for a low cost graphene as well. But you need to mix this graphene, or you need to use along over the lithium so that it becomes low cost again. So graphene having high capacity is good for a fast charge, and having high capacity it is also good for a slow charge, uh, and low capacity as well. So what are the disadvantage that you have? You can have advantage over graphene. Okay. So we have some roadmap for a two-wheeler basically. You see the comparison with different countries, and you see India having 34.68 percentage of overall share of a vehicle for respect to two-wheeler, uh, and you see India will have a total market size of 62 million vehicle, having the US dollar of 62 billion. And what the people says is that the electric two-wheeler would be the next big success story for India after information technology, and we are ahead of even China as well. So electric two-wheeler is going to play a vital role in future with respect to the India, and you can see here India is the largest market in the world, having 60 million units, which will be estimated by year 2030. And out of that, two-wheelers, 72 percentage will be electric. Even government is also going to put rules that after 2030, 2023, all the e-rickshaws and auto which is running should be electric vehicle, no diesel or no petrol. And in the year 2030, the government or the agency may put a rules that whatever the two-wheeler which is running in India, everything should be either it should be two-wheeler. It should be in electric mode. So there is a possibility that the amendment can come. So considering that India is playing a huge market share, and also the survey says that 62 million vehicle, um, out of that 62 million vehicle, that is 5 percentage will be shared by India. And again, the threat is also minimum, and China is also behind India, but India is good for a localization point of view, and they can increase the capacity whenever it's required. Okay. So with this slide, what we can do, we can take some break of 30 minutes, then we can continue. Um, okay. So you see, the two-wheeler electric vehicle is good, optimal for a urban sustainable mobility. So you have the optimum the fuel capacity or fuel saving, where it is 7 times lesser when compared to that of your normal fuel, and the 90% parts you are going to eliminate using the electric system. And it's also having cheaper to maintain, you have less maintenance cost, and it's also good having more storage space as well. You have 80 percentage lesser weight than that of the cars. Two-wheeler is having lesser weight. And when you're taking the urban activities, it's having, you see, 100 percentage is good for diagnosis and real-time tracking. You can track the vehicle, and you can either go for a fast charging or the thing less fast charging, because it's not complicated when for a two-wheeler compared to a car with respect to the charging system. And even the noise is also lesser. As I said, the noise of the engine is too high when compared to that of the electric motor or electric vehicle. So it's again a sustainable one. So you get less heat getting generated. You have less emissions, and with respect to the mobility, it's good having the quicker acceleration. Even you can get better torque, and you can also charge using the system called 1 kilometer per minute charging system. It's also good for the better navigation, and you also have a low center of gravity for a two-wheeler. So comparing to that of the electric vehicle and engines, so we have less maintenance cost in the case of the electric vehicle, and not only the maintenance cost, but again you can save almost rupees 1,000 per month if you are considering 79 roof compared to that of the engine electric vehicle. We can have 1,000 rupees per month savings because you can save rupees 79 per liter of petrol considering 30 kilometer per ride. So considering that, you can have a fuel cost saving of 1,000 and maintenance saving of 250. And again, you also have overall 75,000 over a period of five years, which means you can also buy the new vehicle by saving that much money. So, with respect to two-wheeler point of view, you have less maintenance cost, you have no fuel cost, and again, even some of the financial agencies also leasing you the money to purchase the two-wheeler. So, we'll give some overview about the electric two-wheeler. So, I'm going to compare the Aether 450X and 450 with respect to the 125cc and 110cc scooter. You see, the maximum torque is so much higher, 26 Newton meter in the case of Aether 450X and 20.5 in the case of Aether 450. So you can see the torque is higher, maximum torque is higher, and again the top speed is also quite comparable. And you see that the range per mileage it's 85 kilometer, and you see it's very less in the case of the normal scooter with the engine. And you also get the maximum power as 6 kilowatt, which is quite comparable. And you see the maximum speed, accelerating speed, when you're going for 0 to 40 kilometer per hour, you can reach in 3.3 seconds in the case of Theater 450X and close to 4 seconds in the case of 450. So, and again, this is also comparable, but still you can have better acceleration in the case of the electric two-wheeler. Um, so the price is also quite comparable. So it's like 1.13 in the case of the old Aether vehicle, uh, and it's 5,000 difference between 125cc and Aether 450. But we're going for advanced one 450X, um, which is slightly higher. 50,000 will be higher, but you get the benefit of the savings of water stored here. Okay, so I'm going to compare the Aether 450X again with the Vespa and the Gogaro and the Govex. So here again, the top speed is quite comparable, and maximum power is also quite comparable, and the accelerating speed is quite good, and the battery gap is also good. And you see, yeah, it's having different color display and touch screen also as well, and it's having good connectivity as well, and it's having good software upgrading facilities and technologies. So you see here, the Aether, what is there in India, it's having 99 percentage of the sources are from Tier 1 suppliers. And what these people, Aether company had done is that they want to do localization of all the parts except the cells. Okay, and now they are doing all the localization. They do all the sourcing in house in India. So basically, the make in India kind of thing. Um, and so you see the chassis tool when it is moved to India within 12 months of launch, and the motor and controller assembled being they localized them, and the electronics assembly and also the box bits are also in India. Battery assembly nose is also planned in India. This is the cell one which need bigger investment technologies and manufacturing. So basically, the for India to sell 60 million electric vehicle two wheeler, you need to have 180 gigawatt hour of energy, the cell which is needs to produce that much energy. So, but currently we have 5 gigawatts hour, and it is also cost competitive. And you also have the nickel, manganese, cobalt, and lithium ion phosphate, which is the upcoming battery technology. And this is the scenario now. The scenario at present is the gigawatts hour of cell is not that much available in India. On the other hand, the 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 cost you can also reduce the cost by bringing in the localization. By also not only the localization, the technology is also very important. Um, and you also have the technology's opportunity with respect to the cell point of view. You can also go for a localization of the cell as well. But currently the technology is quite slightly complicated, but still we can try out. And the motor is the next important thing. And currently, not only Ether, all the two-wheeler company, they want to develop uh, the motor technologies, which is highly integrated one. But they are also limiting the hub motors because of our poor roads what we have, and we also go for a higher speed application. And again, this hub motor is also adding unsprung mass to the vehicle, so that's why the people are restricting this hub motor based vehicle. And they also have the technology along with China to use lanthanum plus cerium for the cost reduction and the reliability of the motor. And you can also integrate the electronics for its robustness and optimization. Um, so the Ether Energy, the two-wheeler, so they have the good wiring harness with high level of wireless connection, and they make that as more reliable and also more robust one. So it's having sensors, cameras for the driving system. So it's having good seat storage and frame modularity, having a seat adjustability, and again, this is also a good opportunity you can find. You can also go for a localization of the seat storage area and also the frame modularity. So you have a lot of opportunities for doing the localization with respect to the two wheeler. Okay, so electric two wheeler are evolving. It's not that much matured yet, but still it's delivered the baby, and again, it's slowly the maturity is going to take place now. And again, you have a lot of opportunity for technology driven component makers, and you can also excel in the product technologies. So there is a huge opportunity with respect to a two wheeler. So this is a overview of a TVS Vigo electric vehicle. The TVS Vigo electric vehicle. I will give some overview of the battery management system, and then the the controller, and then the the selection basically, how they select the system. Okay, so when you're going for a two wheeler, what things you need to take into consideration is the friction, the weight of the vehicle, and then the resistance of the vehicle. Resistance indicates the air resistant, and the aerodynamic, and the rolling resistance, and the braking resistance. So all this will have a huge impact with respect to the velocity of the vehicle. Um, okay. Okay. So you have different type of batteries. This basically electric car battery. I will come back to the two wheeler now after this presentation. After this slide presentation, I will come back to the two wheeler. So you see, the lithium ion is quite inexpensive. It's having a easy access, but it's inexpensive. And again, lead acid battery as well. But energy efficient is also quite comparable with all the four batteries. And the temperature performance is good in the case of lithium ion or ultra capacitor. Weight is also quite good. It's quite less in the case of lithium ion. Um, and life cycle is also good between lithium ion and lead acid. So we have different type of motor. Basically, in a two wheeler, it's DC or AC motor. So DC motor is again divided into brushless and brushed. And it's having brush is having serious wound, shunt wound, compound wound, permanent magnet. And the AC is having synchronous or asynchronous, can be either single phase or a three phase. So you have different type of battery, lead acid battery, zinc, and again it's also having nickel cadmium, lithium ion battery. It's also molten solder one, nickel metal hydride, and the lithium ion. So the power to the energy density ratio will vary. We will respect to the different type of batteries that we are what you are going to use. So this is the chain for electric car batteries, which comprises of a 7 step. First is the component production, then is the cell production, then we have the module production, we have the assembly pack, we have the vehicle integration, we use that one, and finally we reuse and recycle it. So the commonly available lead acid battery is cheapest one, and it is also easily available. It's good for charging and discharging as well. Only thing is that it's having some environmental impact, and it's also good for a short life period, and it should not be discharged below 50% of the capacity because of its environmental impact. We also have the nickel metal hydride battery, uh, where the molten chloro aluminum sodium is being used, and the performance is not that much highly efficient when compared to the lithium ion what had been identified as alternative for that lead acid battery. So lithium ion is quite good. It's having high energy density, and but the problem is the explosiveness is too high, and it's good for the performance like state of charge, state of health, and energy efficiency. So you have different motor specification rating for a TVS Vigo one. It's having the 2 kilowatt motor, 40 amps current capacity. So you use 364 lithium ion cells, 3.7 volt each, and this is the standard of the cell what had been combined in the vehicle. So you normally have a nominal voltage of 48 volts. Capacity of the pack is 73.8 amps, ampere hour. So the weight of the cell package is 22 kilogram. Overall energy of the battery pack is 3.54 kilowatt hour. So the maximum terminal voltage what we are going to get of the pack after complete charging is 54.6 volt. So we have different charging time with respect to the current and voltage, and you get a maximum current of 60 amps, and the maximum power what you are going to get is zero point 0.5 kilowatt basically, and the energy of the battery pack is 3.5 kilowatt hour basically. So and again you can also find out how much is the time taken for charging and discharging of the battery, and so here in the case of Vigo, what they use is the battery management system, which is having better the communication data, the monitoring data, and the balancing with respect to the battery pack, and also the collection of the data. So when I speak about the battery management system, it indicates the maximum discharge current limit and also the maximum charging current limit, and also as I said earlier, in it you have different type of terminologies for electric vehicle, which indicates energy, charge, the voltage, and again also the total energy which is required delivered during the first use, and the operating time during the first use, and how much is the number of cycles. So all these terminologies are very important. And we also have the battery management system having two type of communication, external and internal communication. And we also have the closed area network communication, and also we have the wireless communication. This is the example of a battery management system having the lithium battery group. Um, you can see the motor controller, interprocessing units, charger you have, display you have. So this battery management system uh, is a center for controlling the motor, CPU, charger, display, and accordingly you get the sensors which is getting activated, and it also depends on the temperature again. These are different type of components and how it is been connected. It's having a 120-degree phase angle. You have yellow, green, and blue. So this is the motor specification of 750 watts, and rated speed is 2800 RPM, and rated torque is 2.56 Newton meter, and rated current is less than 20 amps. and the efficiency is 80 percentage. Um, and you see the motor specification having the overall length as 268 millimeter and the height as 145 millimeter. So you have a controller, and the controller controls the sensor, brakes, and motor, throttle, and wiring system, etc. So the battery what had been used in the TVS Vigo is having 48 volts, 28 ampere hour, and the energy density is 1056 kilowatt hour, and the power is 1056 kilowatt. So when you want to replace the complete engine with the electric vehicle for a two-wheeler, what you have to do is that you have to remove the engine as a first step to retrofit. You have to build the mountings, and then third step is you need to connect the batteries in series. This is very important. So series, parallel, and plug-in. So you need to see the configuration of the batteries as well, and you need to connect the controller to the motor and throttle, and you need to mount the batteries, motor, and the controller, and also you need to properly fasten it. And finally, last step what you have to do is that you need to connect the batteries to the controller. Okay, so now let us see the importance of the electric vehicle performance. So we have a lot of developed electric vehicle, and we will see how what is their performance. So you have different vehicles. So Renault, Citroen, Peugeot, Skoda. You have different top speed, different range, different efficiency. So I will give one example of a Skoda having the battery electric vehicle having the range of 36.8 kilowatt hour. And you see the acceleration speed 0 to 100 kilometer you can reach in 12.3 seconds. And the top speed is 130 kilometer per hour. And range it can go 200 kilometer, and efficiency is 162 watts hour per kilometer. You can also do the fast charge, and per charge you can go means for 1 hour 170 kilometer. So you have different thing with different OEMs, and these are cheaper fully electric vehicle what I shown, and you also have the higher priced fully electric vehicle where where the cost is 2 lakh 15 euro, which means into 80 will be the original cost. So it's something like 1 crore plus is the minimum cost of the vehicle of Tesla Roadster. Uh, Even you have different ranges in the price as well. Even Porsche is developing the vehicle which already they developed again. So you also have the higher range fully electric cars where the Tesla is playing a vital role, and they seems to be the leading one. This is the vehicle that I shown with respect to the Tesla. Before our break, I have given the example of this Tesla model. Okay, so you also have the Tesla semi truck. You see the vehicle Tesla semi truck. So here, acceleration of 0 to 60 miles per hour, you can reach in 20 seconds. And the mile third range, whatever the range, what you can do is that you can go for 300 to 500 miles per charge. Why performance is important basically? Okay, so the electric vehicle performance is very important because you have the norms called FAME. FAME is nothing but faster adaptation and manufacturing of electric vehicle. So, so you need to implement over a period of 3 years when you are starting from 2019. So which means in the April 2022, you need to launch this FAME scheme. So FAME stands for the faster adaptation and manufacturing of electric vehicle. So you need to go for different demanding system and charging system, and based on that the cost will also get expenditure, and you need to see how you are going to use that incentives for maintaining your battery system or a charging system or the information system, communication system, whatever it is. We also have a different fund which is highlighted here for a different system or sub activities. So almost 10,000 crores have been allocated for this system. Also, you need to have the better electric performance uh, in order to have the better flexibility and also for the breakup. So this electric vehicle performance is very important for the demand incentives, and it will vary with respect to the different vehicle, two-wheeler, three-wheeler, four-wheeler, and four-wheeler with hybrid, even electric bus as well. So it having different battery capacity, and the incentives are accordingly it will vary. For a bus, they are giving the incentive for 50 lakhs, up to 50 lakhs they give, uh, and uh, and for a two-wheeler they give 20,000. So again, it depends which one you are going accordingly. You have the different incentives, and you also get the different funding from the concerned authority. Okay, so as per the Directorate of Urban Transport, Government of Uttar Pradesh, what they have done is that they have taken the specification with respect to the electric vehicle performance data. So they have compared the length with the height of the vehicle as per the norms or the standards, what they call. So they also consider the dimensions for the overall height of the vehicle, and also for the propulsion system like electric motor, and they also have the homologation requirement. They have the power requirements. They also have the electric power system. So they need to see, uh, considering that the electric vehicle performance is very important. So you have different type of vehicle like two-wheeler, three-wheeler, four-wheeler, and different cabs, and accordingly you need to do the homologation for different category. If it is L5, then it is called electric two-wheeler or a auto or a rickshaw kind of thing, and L1, L2 is nothing but electric two-wheeler, and N1 is for a light commercial vehicle or a carriage vehicle. So you have the different range, minimum range, and the maximum energy, and you can also you need to see what is the minimum and maximum speed that a particular two-wheeler or three-wheeler needs to undergo while you're going for a FAM eligibility test. And you should also ensure that you need to have the minimum acceleration for the different vehicle category. So first one is the performance. Then after that, you need to evaluate things. How you are going to evaluate? So you are going to evaluate the electric vehicle or hybrid electric one. So using the simulation, you have the different drive cycles. You have 256 drive cycles are available, and it's been followed globally. To name few, you have different types of drive cycle like US driving cycle, NEDC, and you have FTP, Federal Test Procedure. You have the Europe legislative cycle. So you have different type of thing, and even Japanese people follow different cycle. So it will vary from country to country. But overall, 256 type cycles are available. So I have mentioned the three driving cycle. One is New European driving cycle, where the average speed is 120 kilometer per hour, whereas in India the average speed is 90 kilometer per hour. The average speed in America is 140 kilometer per hour. So we also have the test cycle like World Light Harmonized Test Cycle. This test cycle is been followed for a two-wheeler and light duty vehicle. Basically a three-wheeler kind of thing. Also, we also followed for the ECE 15 drive cycle, which is the drive cycle which has been used for a Europe application. Okay, so when you're doing the simulation, you also need to see the kinematic behavior of the vehicle with respect to the time, speed, acceleration, and start stop technologies, etc. So when the vehicle is moving, the dynamics point of view, you need to see the the motion or the behavior of the vehicle when the vehicle is running in the moving condition. So we follow different test cycle, and to mention few new European cycle, driving cycle, FTP Federal Test Procedure, which is followed in New York and some of the US states, And Japanese also they follow the test cycle they call JP10 mode, where the distance, duration, the average speed will vary. Okay, so when I say the evaluation, the test procedure for electric vehicle evaluation, you also need to do some homologation. Okay, so something about vehicle regulation. So you need to do the homologation for a vehicle. So you need to follow the standards for electric vehicle, hybrid electric vehicle. So you also have some standard for a retrofitment, simply converting the conventional vehicle to electric vehicle. And you need to you need to understand all those standards, and you need to carry out the evaluation accordingly. So you have different standards name like AS 03839 and revision 1, and these are the reference standard number. So say for example, if I say AS 039, which is for electric energy density consumption. So here this test is used for driving cycle on the chassis dynamometer. You see that vehicle is running in the chassis dynamometer. So what they do is they will measure the energy required per kilometer. So how much is watts hour per kilometer, and they also measure the measurement of range. How much is the range it's coming in one full charge, and they also do the maximum power test. They do the electric vehicle some specific trial, like the calibration test or the noise test or EMC test or the gradability test. They do different thing depending upon the requirement. Okay. So you have different batteries, and we have different material for those batteries. So even the cobalt is also the good options. It's having a high conductivity, high energy density, and high structural durability. Even this cobalt is also an alternative that battery manufacturers can look into it. And the world's largest cobalt manufacturing means the presence of cobalt is more in Congo state. Um, Unfortunately, in India, it's not that much high, but even cobalt is also the major resource that we can look into it for high conductivity and high energy density. Okay. You see this some of the terminologies which is very important. I told about you the state of charge, state of discharge, the specific capacity, etc. So here, this is the battery having the stored energy between the top empty and the bottom inactive. So here, the state of charge is indicating the uh, stored energy along with the inactive part. So, so it's a SOC or state of charge is summation of stored energy plus inactivity, and the rated capacity is nothing but the overall capacity of the battery, not only the energy of store that is stored, but also the empty and also the inactive one. So the available capacity is nothing but it represents the actual play field between the stored energy and then the empty. So you need to understand the specification of the battery, and accordingly you need to select it. Volt is V is equal to IR. When voltage is higher, the current will be higher. So you can also experience that by charging your own mobile phone. So I have two port, one having 2.5 volt, another having 3.5 volt. So when I use 3.5 volt, my mobile phone charger gets quicker charging. So considering that, you can also play V is equal to IR principle even while we're going for a state of charge and state of discharge with respect to the voltage, current, and accordingly you can have the charging and discharging as well. So the next graph here is um, a kilometer which is traveled in x-axis or the number of cycle. So one cycle is having 250 kilometers. So you can see you can see the driving range. Even the top is also grace capacity and the bottom is also grace capacity. So the driving range always comes between the stored energy, what we basically call. So here, when the battery is getting charged, or when the battery is getting operated, so after 75 kilometers, after 75,000 kilometers, it gets means the performance gets degraded, and 5%, 12% loss will happen. But if you do some software adjustment, you can adjust to some extent, but beyond some particular kilometer, still you cannot retain its originality, and again it will take some time, even after you do some adjustment. So beyond particular speed, or beyond particular kilometer per cycle, you cannot adjust the software. So for which you also have the deterioration. So the deterioration will be more when the cycle is getting increased, which means when the distance traveled is getting increased, your deterioration percentage is also getting increased. So this is the odometer miles in x-axis, and you have the range in miles in y-axis. So you have the different range. One is the oversized battery with great capacity, and the fading battery avoidance when the energy band is on the higher side. And as I said in the previous slide, you need to do some software adjustment to reduce the stress. Stress here is nothing but the deterioration basically. But beyond certainty, you cannot reduce the deterioration. Still, it will increase only even after doing the adjustment of the software. So this is a graph having the battery charging and discharging. So I'm giving the taken the example of four temperature: 10 degree, 25 degree, 40, and 55. When the temperature is increasing in a battery, um, what I can get is the relative capacity gets decreased. Okay, but uh, what is called relative capacity? The when the temperature is getting increased with respect to the battery of the stored system, and the grace or the empty, and then the inactive part. So here what I can able to find is that when the temperature is getting increased, the relative capacity of the battery gets reduced. On the other hand, when the voltage is on the higher side, the state of charge will also be on the higher side. So you can see the 4.1 volts having 90% of state of charge, whereas 3.45 volts is having only 14% state of charge. So you can find the difference. So the charging the battery, uh, or the system is basically a function of a temperature. So when temperature gets increased, accordingly it will have the influence on the charging time, and then power as well. And again, accordingly the state of charge percentage will also vary with respect to the time. So here it's uh, taken 5 degree, 25 degree, 40 degree, and 50 degree. So when I say it's 5 degree, you can see that the charging power, which is highlighted in blue. And again, this performance will also have the impact with respect to the state of charge. So when I say the state of charge here, when the voltage is 4.1 volts, is 90% charge. Whereas when the voltage is 3.45 volts, it is only 14%. So it's not only the voltage, but also uh, the, the temperature is also playing a better role. So temperature plus voltage plus current will have the influence on the battery charging performance. So finally, I'm going to now close the presentation with the help of a case study. Uh, the case study here is the mathematical modeling and simulation of a electric vehicle. So the electric motor torque and efficiency. The efficiency of the motor is the product of output power and input power. So input power is basically output power plus you have some losses. So the it's basically a power loss. Okay, the power loss. How I'm going to uh, approximate with respect to the mathematical system or equation. So you have the loss, power loss, which is indicated in terms of the equation, which is depending on the copper loss coefficient and also iron loss coefficient and constant power losses, windage losses, motor torque, and also the motor speed. This is the mathematical modeling and simulation of electric vehicle. You have the battery, you have the battery controller, you have the vehicle interface, motor controller, and power electronics. So this electric vehicle, what had been taken for a modeling activity is of a lithium-ion storage one, and we can able to generate more than 200 watts volts. Okay, so this is quite interesting with respect to the modeling point of view. You have basically four system or four quadrant. First quadrant is the forward motoring, where you have the torque, positive torque, and positive speed, or what the speed is nothing but RPM. When speed and torque both are in positive, then you can say the vehicle is having the forward motoring. So the reverse regeneration is the one having the positive torque and negative speed, and the reverse motoring is the one having both torque and speed negative. And the last one is the forward regeneration, where the torque is negative and speed is positive. So you need to consider this thing while you're going for a modeling or a simulation. Okay, for a DC motor, the torque which is developed in is nothing but TD, and it's directly proportional to the armature current, which is nothing but IA, and Km is nothing but the motor constant depending on the winding construction of the motor. So you also have the torque or the voltage which is developed in the motor, which is nothing but VD, which is also based on the proportional speed of the armature speed. It's measured as omega d. So Km is nothing but the motor constant, and again omega d is the armature speed, and that will also determine the voltage which is getting developed in the motor. Okay, so here you have two type of voltage at a high speed and high at the high side, and voltage at a low side. So first I will explain about voltage at a high side. So voltage at a high side or high current, high voltage and high current, it's basically input kind of thing. So here it is dependent on two factor called VL and IL, where VL and IL is nothing but the current when it is in the low side of the output, and the voltage at low side of the output. So you need to consider both the voltage and then the current with respect to whether it is on the higher side or on the lower side. So here you need to also understand that you're going to consider the zero loss and no time lag while you're going for a modeling of the electric vehicle. So you take the battery which is been modeled as the voltage source, where VL is directly proportional to IL, and it's also depending on the high side or low side, the battery and voltage and the current. So you also have the error which you need to adjust with the help of the software. I told already you need to go for a software adjustment, and by going for you can also need to consider the PID system, uh, and finally what you can also see, you get the output with the help of the proper input what you are going to give with respect to the time, and also with respect to the speed, and also with respect to voltage current. So you get the output, and you see here you need to consider all the factors with respect to the traction force as well, because it's not only the you are going to consider the motor or the battery management system or the controller alone, but you also need to consider the tractive force of the vehicle, which is based on the aerodynamic structure plus rolling structure, and also it's based on the braking effect of the vehicle. So you need to consider all those things while going for the mathematical model or simulation. You see, auxiliary load which is coming under passenger car is having the radio, HVAC, lights, plus auxiliary things. So it's having different load in terms of watts. So and again, these loads are not constant. The power consumption will also vary with respect to the surrounding temperature. But based on the research and data what have been shown, these values are averaged. So this is the mathematical modeling that we can do using different software. We have the Ricardo you can use, or you can also use go. You can also go for uh, kit kind of simulation software for uh, for carrying out the mathematical modeling. So here you use PID controller. You can also you can give different conditions with respect to speed, torque, power. Accordingly, we have different voltage, current. So finally, we can get the output desired as desired with respect to the power and etc. So you see here. So this is the output that you are going to get. So you see when the vehicle is running the first quadrant motoring, and when the vehicle is running the fourth quadrant regeneration. So this is how the time versus the power behavior. And you see the output, the simulation output. So we get the motor voltage, what is the motor current, what is the motor power, and we get in both in high state and also in low state. You see the function again with respect to some of the software adjustment, the gain factor what you have. You can also accordingly you can get the battery and then battery current and also the voltage accordingly you can have. Thanks for an opportunity. You can ask me questions now. I have 15 minutes time. You can ask me the questions. I will answer. And beyond 15 minutes, you can me at p.arjunraj@gmail.com, or you can also call me at 87789834228. Thanks for an opportunity, and I look forward for your questions. Please ask your questions now. Okay, which means you can email me if in case if you don't have a doubt. You can email me, and I will answer. Offline. Thank you. Thanks a lot.